Hi everyone, in today's video we are going to start solving polynomials by applying the remainder and factor theorems. So you're going to learn how to use synthetic division to divide the polynomials and then apply the remainder and factor theorems so that we can factor them, find solutions, and even graph rough sketches. So let's go ahead and get started. We are going to use the term synthetic division today, but it is the same thing that we did last time with synthetic substitution. We're just using it to divide out rather than to evaluate now. So our steps are going to be the same initially. We just are going to add some more steps today. So in this first example, we are going to divide the polynomial by x minus 2. So just like before, we have this divisor x minus k, and k is going to be what we're dividing out in the synthetic. So for the divisor x minus 2, we are going to be using 2 to divide out our polynomial. So I'm going to write the 2 on the outside. Remember that we are going to write the coefficients starting with the highest degree. We're going to go in descending order or standard form. So I'm going to write all of those out to make sure I'm not missing anything. And then I'm going to put the coefficients in their corresponding spots. Okay, I have it set up, so I'm going to multiply on the outside and add on the inside. So I'm going to bring down the 1, then I'm going to do 2 times 1 is 2. I'm on the inside now, so I'm adding to get 4. Multiplying 2 times 4 is 8. Now that I'm on the inside, I'm adding negative 6 plus 8 is 2. Multiplying again on the outside, 2 times 2, and then adding to get negative 5 at the end as my remainder. So I have these, the synthetic now, and I'm going to write a new polynomial with this information. It's going to be called the depressed polynomial. I like to think about it that he's sad because he lost one of his, he lost a divisor. He lost the x minus 2. So I'm going to use these coefficients, not including the remainder first, and then I'm going to use the remainder afterwards. So because I divided out x minus 2, the polynomial is going to lose one of its degrees. So instead of being an x to the third, it's now going to be x squared as our first term. The coefficients I'm going to pull from my solutions down at the bottom here. So I'm going to pull down the 1, then I'm going to pull down the positive 4, and go again. We're going in descending order for standard form, so that's x to the first power. I'm going to pull down this positive 2. That's going to be x to the 0 power, which is just the constant term. So I'm not going to write the x to the 0. So I have x squared plus 4x plus 2. And then my remainder is going to come down, and I'm going to put him over the thing that I divided out. So this x minus 2 divisor is going to become the rest of my fraction. Now this is the same as when you were in elementary school learning long division, and say you did 5 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. And then when you subtracted and you got this remainder of 1, you wrote that as 2 and 1/2. So the thing that we're dividing out went into the denominator of the remainder here. The same thing is happening. The thing that I'm dividing out is going into the denominator of my remainder. Okay, so this guy here is our depressed polynomial. He's sad because he lost his factor of x minus 2. All right, so let's look at when this can be useful to us. We have 2 theorems that are going to help us to take synthetic division and do lots of great things with it. First is the remainder theorem. And the remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder r is equal to f of k. Now when we put that with the factor theorem, which says a polynomial f of x has a factor of x minus k if and only if f of k equals 0, this is where our kind of greatness for today's lesson comes from. Because what this is saying is that if you divide out x minus k and you get a remainder of 0, then it's a factor. So it's going to help us to factor polynomials that are higher than degree 2. So what does it mean if you get a remainder of 0 when using synthetic division? It means that the value you divided out is a factor. When you write the depressed polynomial, you might be able to use additional factoring in the zero product property or any other form of solving that we did earlier this year to solve the polynomial. So we have a method for solving now by using the remainder and factor theorems, because our remainder is going to be 0 when we factor by dividing out using synthetic. Okay, so let's look at a couple of examples of that. This problem says factor f of x completely given that x minus 8 is a factor. So if I know x minus 8 is a factor, that means that I know x is equal to 8, and I know that x minus 8, that quantity, is going to be one of my final factors. So let's use that solution, x is equal to 8, to do my synthetic division. So I'm going to write the 8. I'm going to set up my synthetic. I'm going to start with my degree 3 coefficient, and I'm going to go down to the constant term. My coefficients are 1, -2, -40, and -64. And then I'm going to do my synthetic. So I'm going to bring down the 1, I'm going to multiply, and then I'm going to add, I'm going to multiply, then I'm going to add, then I'm going to multiply, and then I'm going to add. Okay, and here's where this is a big deal. I just got that my remainder is 0. That is great news because I was told that x minus 8 is a factor. If you don't get a 0 here, it means either you did something wrong in your synthetic, either the setup or the process, or that the thing that you're dividing out is not actually a factor. So since this told me that x minus 8 is a factor in the directions, it means I have to get 0 as my remainder. I know if I get anything else that I've messed up somewhere. So that's a nice little check in place. So now we're going to, as step 2, write the depressed polynomial, because then we're going to be able to factor further. Now because we got a remainder of 0 here, we're going to write the depressed polynomial as 2 factors being multiplied together. The first one is the factor that I already know. I know that x minus 8 is a factor. And then I'm going to use these coefficients to write the other piece of my depressed polynomial. So because this was x to the 3rd, I'm going to start with x squared. That leading coefficient is a 1. Then I'm going to bring down my plus 6. That's x to the 1st power. And then I'm going to bring down my constant of plus 8. Because there's this remainder of 0, I don't have anything else to write here because I've written my x minus 8 factor already. Okay, so now I have something that looks much easier to factor because this piece is something that we've factored a lot so far. So I'm just going to copy down my x minus 8 again. He's just kind of along for the ride, and I'm going to factor the quadratic. I'm going to factor to x plus, and let's see, whoops. We're going to use, what are we going to use here? We're going to use 2 and 4. So x plus 2 and x plus 4. And then I have factored this completely. Oh my goodness. All right, so I factored that completely, which means x minus 8 times x plus 2 times x plus 4 is my completely factored polynomial f of x that started as a 3rd power. If I were to FOIL all of these or distribute all of these back together, I could check because it would give me back my original problem. Okay, so now let's add a step. If we have 1 0 of the polynomial is 4, that means x is equal to 4 because remember zeros are solutions or x-intercepts. It also means that we know that one of the factors is x minus 4. So then we can now, instead of using synthetic just to factor, we can take it one step further and use the zero product property to find all of the solutions. So let's find all of the zeros. We're going to start with our synthetic. So we're going to set up our 4. We have x to the 3rd, and then we're going to go in descending order from there. So that's 1, 1, -16, and -16. I'm going to bring down the 1 and then quickly go through my multiplying and adding. All right, so when I get to the end, I again have a remainder of 0. That's good. It means I didn't make any mistakes because I know that my 0 is 4. So now we're going to write it as a product of two factors. I'm going to write my original factor that it told me through the 0, x minus 4, and then I'm going to use these coefficients for my depressed polynomial. So this was x to the third, so I'm going to start with x squared because we divided 1 out. The coefficient was 1. Then I'm going to write plus 5x plus 4. And then I'm going to write equals 0 because we're trying to solve this if we're finding all of the zeros. All right, so from here, I can either factor this or I could use another method if another method worked better. So you have quadratic formula in your back pocket, you have square root method, you have completing the square if you need it. This one is going to factor, so I'm just going to keep factoring. So I'm going to write x minus 4, and then I'm going to factor this second piece, the quadratic. That's going to be x plus 1 times x plus 4. And then I'm going to use the zero product property to solve. So x in this first factor is equal to 4. In the second factor, x is equal to negative 1. And in the third factor, x is equal to negative 4. So I have found all three of my solutions there. Now, just as a quick note, whenever we're solving polynomials by using synthetic and setting it up as the depressed polynomial and factoring it, we can use our solutions to do a quick sketch. So let's look at what that rough sketch would look like. I know what my solutions are, and remember, solutions are another word for x-intercepts. So I can graph or plot all three of those x-intercepts, all of my solutions, and then I can use my knowledge of end behavior to figure out which way my ends are going. If we look back up at the original polynomial here, this was a third degree polynomial. So that degree is odd, which means that my ends are going to go in opposite directions. The leading coefficient is positive, which means that I'm roughly going to have an increasing line. It's going to go down on the left and up on the right. So I'm going to draw those arrows down on the left, up on the right. And then I need to think about my multiplicities when I look at factored form, which is this guy right here, to figure out bouncing and crossing. All of these have a multiplicity of 1, which means that because all of the multiplicities are odd, I am going to cross at all three x-intercepts. So I'm going to start on my left at my arrow. I'm going to cross, curve over, cross again, curve over, cross again, and go up to my arrow. And now I have a rough sketch of my polynomial. So synthetic division allowed us to do a lot here. It allowed us to verify that we have a 0 or an x-intercept. It allowed us to write a depressed polynomial so that we could factor, and then we were able to use, in this one, factoring and zero product property to get solutions, which helped us to draw a rough sketch. So let's do one more. This one does have a little bit of a doozy at the end, so I want to show you a harder one too. All right, so let's work through all of these steps. 1 0 of f of x is negative 3. Find all the zeros. So if I know x is equal to negative 3, I know one of my factors is going to be x plus 3. We're going to use that in a little bit. So let's go ahead and set up our synthetic so we can set up a depressed polynomial that is easier to factor. So I'm going to write all of my coefficients. That's 1, 1, 2, and 24. And then I'm going to do my synthetic. So I bring down my 1, I multiply, I add, I multiply, I add, I multiply, I add one more time, and I get a remainder of 0, which is good. That means x plus 3 is indeed a factor. All right, let's write out the depressed polynomial now. So the factor that I just verified is x plus 3, and then using my synthetic division for my coefficients, I have x squared minus 2x plus 8. And all of that is equal to 0. So now I am looking to factor because that is going to be my quickest and easiest. But when I look at this, I need to use the same signs to get an 8 when I add or 8 when I multiply, and a negative 2 when I add. And that's not going to happen. I can't use 4 and 2 without using different signs, and I'm not allowed to use different signs. So factoring is not going to be a way to solve this one. I have to use one of my other quadratic methods. And the quadratic formula is calling my name right now. So I think we're going to try plugging this second factor into the quadratic formula. All right, so remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So I'm going to change my color so this doesn't get too messy, and we will set all of that up. All right, so we have x is equal to negative b, and b is negative 2, so that's negative 2 plus or minus the square root of b, which is negative 2, quantity squared, minus 4 times 1 times 8. And that is all over 2 times a, which is 1. Okay, so let's see what we can do here. Negative 2 is positive 2. And then we've got that plus or minus. Then we have negative 2 squared, which is 4. So that's 4 minus 32 on the inside. Oh, we're going to have an imaginary number here because we're going to have a negative. All right, so we've got 2 plus or minus the square root of negative 28 all over 2. So now 28 is 7 times 4. So the 4 I can take out of the radical because square root of 4 is 2. So I have 2 plus or minus 2i, because of that negative, square root of 27, or sorry, not 27, just 7. And then all of that's over 2. And then I'm going to take this common denominator and break it into 2 fractions so that we can do a little bit more simplifying. So that's 2 over the denominator of 2 plus or minus 2i square roots of 7 over the denominator of 2. So then 2 over 2 is 1, and 2 over 2 is 1 again. So that's 1 plus or minus 1i square roots of 7. And that's simplified all the way. So now, putting together what we have, remember our goal was to figure out what the solutions were, the zeros. So I knew one of my zeros from the beginning. It was this x is equal to negative 3. Remember, that's where that factor came from. So my final solutions are the negative 3 that I was given, and also the 2 solutions that I found with quadratic formula. 1 plus I square roots of 7 and 1 minus I square roots of 7. Goodness, I don't know what's going on with my computer today, guys. All right, so there are my zeros for that one. That was a little more work because I had to use quadratic formula. Always try to factor your depressed polynomial first, but if you can't, remember you've already also got quadratic formula in your back pocket. So you are now able to use synthetic division to divide polynomials. And then once you've done that division, you can use the remainder and factor theorems to factor polynomials, to find solutions, and to even do rough sketches of the graphs. Go ahead and try those now you try problems now.